Page 1, Physics Seminar 1 Scaffolded in-class worksheet. 1. Context. This worksheet focuses on the topic of kinematics, with a particular emphasis on projectile motion, the two-dimensional motion of objects under constant gravitational acceleration. The horizontal and vertical components of motion are treated independently, and kinematic equations are applied to determine quantities such as time of flight, range, and initial speed. The goal is to deepen understanding of the relationship between position, velocity, and acceleration in a physical context. Preliminary discussion. Before attempting the main problem, consider the following conceptual questions. Question 1. Is it physically possible for an object to have a non-zero acceleration at the exact moment when its velocity is zero? Provide a brief justification based on motion you are familiar with. Yes, for example, at the top of a projectile's path, its vertical velocity is zero, but it still has downward acceleration due to gravity. Question 2. A ball is projected horizontally from the edge of a table. At the same time, a second ball is released from rest and falls vertically from the same height. Assuming air resistance is negligible, which ball hits the ground first? Justify your answer. Both hit the ground at the same time because they have the same vertical acceleration and start from the same height. The problem. A basketball is released from a height of 2.00 meters above the floor at a horizontal distance of 10.0 meters from the basket. If the ball is shot at a 40.0 degree angle with respect to the horizontal, at what initial speed must it be thrown to pass through the hoop without striking the backboard? Assume the basket height is 3.05 meters, air resistance is negligible, and take G equals 9.80 meters per second squared. Page 2 tasks 1. Which force or forces act on the ball during its flight? Only gravity acts on the ball, directed vertically downward. 2. Does the ball accelerate in the horizontal direction? No. Vertical direction? Yes, with acceleration. G equals 9.8 meters per second squared downward. 3. Describe the type of motion in each direction. Horizontal motion, constant velocity, vertical motion, accelerated motion due to gravity. 4. Define your coordinate system clearly. What do x equals 0 and y equals 0 represent in your setup? Let x equals 0, y equals 0 be the launch point. Then x equals 10.0 meters, y equals 1.05 meters at the hoop, since 3.05 meters basket minus 2.00 meters launch height equals 1.05 meters. Page 3. 5. Resolve the initial velocity vector into its components. Why is this step important? Horizontal component of velocity v0x equals v0 cosine 40 degrees. Vertical component of velocity v0y equals v0 sine 40 degrees. Why do we resolve the velocity vector? To analyze motion in each direction separately, since horizontal and vertical motions are independent. 6. Write the equations of motion. A. Horizontal direction, x of t equals v0 cosine of 40 degrees times t. B. Vertical direction, E of t equals v0 sine of 40 degrees times t minus 1/2 gt squared. 7. Use the parametric equations to form a single equation with one unknown. A. Write an expression for t from the horizontal equation. T equals 10.0 divided by v0 cosine of 40 degrees. B. Substitute this expression into the vertical equation. Y equals v0 sine of 40 degrees times open parenthesis 10.0 divided by v0 cosine of 40 degrees close parenthesis minus 1/2. G times open parenthesis 10.0 divided by v0 cosine of 40 degrees close parenthesis squared. C. By now, you must have obtained one equation with only one unknown, v0. Solve it and give the answer to three significant figures. Solving y equals 10.0 tangent of 40 degrees minus the quantity 9.8 times 100, all divided by the quantity 2 times. v0 squared times cosine squared of 40 degrees equals 1.05. Solving numerically gives v0 equals 10.7 meters per second. So, to recap, We broke the problem into horizontal and vertical components, used the kinematic equations, and solved them simultaneously by eliminating time. This is a powerful strategy for any projectile motion problem. Thanks for watching, and see you next time.